Why do a fan have capacitor? Any single-phase motor is used in fan consists of a stator and main winding with a rotor shaft. Now with alternating current supply to the stator winding, alternating flux is produced which then induce a current in the primary winding. Let's learn about this through the diagram. The diagram represents the circuital arrangement of the fan. According to the diagram, it has one running and one starting winding, also known as stator, connected to the power supply. One capacitor is serially connected with the starting winding and one rotor. Here the starting winding has low inductive reactance but high resistance, while the main windings have high inductive reactance but low resistance. Now let's consider an electrical fan circuit without any capacitor. Now with the switch closed, the circuit is complete. A 230-volt alternating current flows through the starting and running winding. This produces a non-rotating but pulsating magnetic field from 0 to 180 degree intensity. When we have the same phase for two winding, no magnetic rotation will be created, hence the rotor will not be rotated for this type of arrangement.
When we have the same phase for two winding, no magnetic rotation will be created, hence the rotor will not be rotated for this type of arrangement of the fan without a capacitor. To create magnetic rotation we have to create two different phases for two different winding. Now since we have a single phase connection at home we can't make two phases to give. To overcome this problem, capacitor is used.
Now let's consider the circuital arrangement with the capacitor, which is serially connected to the starting winding. Now when the switch is closed, the same 230 volt AC is entering the running winding and capacitor. The phase that gets enter into the capacitor will get shifted 90 degrees in phase inside capacitors and comes out, and now this shifted phase is entering into the starting winding while the applied phase is in the running winding. Due to two different phases in each winding, the magnetic rotation will be created and thus cause the rotor to rotate. When the motor speed reaches about 70% of its synchronous speed, the capacitor along with stator winding is disconnected using a centrifugal switch. The capacity of the capacitor is chosen based on the initial load torque requirement and are generally 2.25 microfarad.